Hello. Welcome to today's lesson on heat transfer, namely energy transfer in a circuit with reference to collisions, the heating effect, and thermal dissipation. We will start by understanding the relationship between energy transfer and the heating effect in an electrical circuit. We will then cover the advantages and disadvantages of the heating effect. In the energy unit, you have delved into energy types and how energy can be transferred from one form to another or from one object to another. You also have a solid foundation in understanding circuits, voltage, and resistance. Today, we will examine a real-life phenomenon where those principles come into play. Let's look at energy transfer and heating effect in a circuit. To understand the heating effect in an electrical circuit, let's begin with what happens when electrons move. In a circuit, a battery provides the driving force that pushes electrons through the wires and components. This is a transfer of chemical energy from the battery to kinetic energy in the electrons. As these electrons travel through the circuit, they don't move unimpeded. Instead, they collide with the atoms in the material of the components, like wires or resistors. Imagine a crowded hallway where people keep bumping into each other as they try to walk through. The electrons experience similar collisions. These collisions are crucial because whenever an electron collides with an atom, some of the kinetic energy of the electron is transferred to the atom. This transfer of energy causes the atom to vibrate more vigorously. The increased vibration of atoms means that the thermal energy store of the material has increased, leading to a rise in temperature. In simpler terms, the material heats up. This is called the heating effect. The heating effect occurs when an electric current passes through a conductor and generates heat. It is unavoidable and happens in every electrical circuit to some extent. The more collisions that occur, the more energy is dissipated as heat. So what are the advantages of the heating effect? The heating effect can be extremely useful in devices specifically designed to produce heat. For instance, electric heaters use this principle to warm a room efficiently. Toasters make use of the heating effect to turn bread into toast. Kettles benefit from it to quickly boil water. In these examples, the heating effect is advantageous because the heat generated by the electric current is a desired output applied to a specific task. However, there are disadvantages to consider. In some cases, the heating effect can be undesirable. Firstly, not all devices are intended to heat up, and in such cases, the heating effect represents wasted energy. This can be a significant disadvantage, making the device less efficient overall. For example, in a computer, excess heat is an undesirable byproduct. Excessive heating is also harmful to the components themselves. Over time, the heating effect can cause materials to degrade, reducing their lifespan and effectiveness. This is especially problematic in complex electronics where precision and longevity are crucial. Additionally, overheating can pose safety hazards. Uncontrolled heat can lead to burns, fires, or other dangerous situations. For example, a phone battery overheating may catch fire. This is why cooling mechanisms, such as fans or heat sinks, are often used in electronic devices to avoid the undesirable consequences of the heating effect. In today's lesson, we examined how energy is transferred in electric circuits and focused on the role of collisions, the heating effect, and thermal dissipation. We discussed how electrical energy is converted into other forms of energy as electrons move through a circuit. We also covered the heating effect of electrical current, which explains how appliances like heaters and incandescent bulbs convert electrical energy into heat and light. We also considered the disadvantages of heating effects, including how degradation of components by the heating effect can lead to risk of danger.